have the rational numbers and the irrational numbers. Rational numbers and the irrational numbers. So first let's go through what are rational numbers. Rational numbers. So the notation of rational numbers is Q. Okay, you'll present with a special Q. Okay, so rational numbers. Any number that you can represent as a fraction. Any number that you can represent as a fraction. So the set of rational numbers will be what? A divided by B. So if you can represent a number, if you can represent any number as a fraction, this is a fraction, right? A divided by B, A over B is a fraction. So if you can represent any number as a fraction, that is called a rational number. So what is A and B? A comma B belongs to, okay, this symbol is belongs to, this is set notation, okay? So A divided by, first you write what is A and what is B. Here you can see we wrote the set notation as elements, right? 1, 2, 3, okay? So this is another way of writing set notation. So here we write A divided by B. Q is A divided by B, okay? Q A divided by B such that A and B belongs to integers. A and B belongs to integers, okay? A and B belongs to integers, and there's another condition, and space is not enough, so let's make it. Q is equal to what? Again, A divided by B such that A comma B belongs to integers and B not equal to 0. B cannot be 0. So this is what you call by 4. 4 can be expressed as a fraction. So which is 4 divided by 1. Okay, so that is a rational number. Then let's say this is a whole number. Then we have, let's say, 4.1. 4.1 is a decimal number. So we call this type of decimal numbers as terminating decimals, or that's a finite decimal. So this is not going like this, it's not recurring. I mean, this is only one decimal place is there, then it is going to stop there, right? So these type of decimals are called finite decimals. So this we can express as a fraction, 41 divided by 10, right? So 41 divided by 10. So I will give you a little bit basic information. So if you say any number, let's say 55 divided by 10, whenever you divide a number by 10, you will go one decimal backwards, right? So that means 5.5. If you divide by 100, you will go 2 decimal places backwards. If you divide by 1000, you will go 3 decimal places backwards. So likewise, I can write 41 as a fraction, that is 41 divided by 10, right? So that one also I can express as a fraction. Okay, then what about 1 divided by 3? 1 divided by 3. 1 divided by 3 is what? You can see 1 divided by 3. You have 0, then you have, for 10, you have 3. 3 times 3, 9, 1, 0, 3. Then this is going to continue forever, right? 3, this will never stop. 1. So likewise, it is going to go 0.3333333. It is going to continue for forever. So I can write 3, 3, 3, 3, like that. It's going, right? So this is not a finite decimal. So this is called a finite decimal. So a finite decimal can be expressed as a fraction, Also, 1 divided by 3 can be a finite decimal, right? So in your syllabus, you don't have it's not there to convert a recurring decimal. We call this type of decimals as recurring decimals. So this we can express as 0. recurring 3. We are going to keep a small dot on the top of the recurring number. So this is going to repeat forever. So this type of decimals are called recurring decimals. Recurring decimals or recurring numbers, right? So this 3 is recurring, right? It is going to be 0.3333. It is going to recur till forever, right? So these are called recurring. And if this is finite decimal, this type of decimals are going to be infinite decimals. This is finite, this is infinite. So those are the two types of decimals. So both, you can see both the finite decimals and recurring decimals we can express as a fraction. So both of them belongs to rational numbers. So 1 divided by 3 or 0.3 is going to be a rational number. So this this 4.1 is also going to be a rational number. Yeah. So these are the examples for rational numbers. Again, once again, any number that you can express as a fraction is called a rational number. Then we have irrational numbers. Irrational numbers. So if rational numbers means the numbers that I can express as a fraction, right? Any number that I can express as a fraction is called rational numbers. Then what are my irrational numbers? The numbers that I cannot express as a fraction, right? Obvious, right? If rational means can express as a fraction, then irrational means cannot express as a fraction. So what are the numbers that I cannot express as a fraction? Suppose we have square root 2. Okay, square root 2, the value of square root 2. You can, you can use a calculator to find. If you use a calculator to find square root 2, you will get a very long answer. Even in your textbook, I think it's there. 1.4142135 and it is going to go forever, and there is no pattern. And it's not, none of the numbers are recurring. So this is going to be different numbers. So if it was something like this, if the answer was something like this, 414 414 414 414, so something like this. Okay, if the answer was something like this, 414 414 414, so you can see 414 is repeating, right? 414 is repeating. So in that case, this is a rational number. Why? The same set of numbers are repeating, right? So this is a rational number. But if you use a calculator to find the square root of 2, the answer you will get is something, no pattern at all. There will be no pattern, but different numbers, 4 1 4 2 1 3 5 6, like that, different set of numbers without any pattern. So these types of numbers we cannot express as a fraction. These types of numbers we cannot express as a fraction. Okay, so these are called rational numbers. These are called rational numbers. So square root of many numbers like square root of 5, square root of 7, square root of 11. So all these numbers are irrational numbers. We cannot express them as a fraction. Okay, then what about pi? What about pi? So pi is a irrational number. But someone would ask me, when we find the perimeter or when we find the area, we use 22/7 as is equal to pi, right? We use pi is equal to 22/7. Then that means I can express pi as a fraction, right? 22/7 means fraction, right? Then why now I'm telling, now this is telling like I cannot, like pi is a irrational number. So pi is a irrational number, but still I use 22/7 as pi. So what is the reason? I mean, if I can express pi as a fraction, it should be a rational number, right? No, it is not a rational number. It is an irrational number. Why I am telling so? So if you find the actual value of pi, it is going to be 3.14 something very different number. Okay, but this 22/7 is an approximation. This is not the actual value. This is actually not equal, or we can say approximately equal to. Pi is approximately equal to 22/7. It is not the actual value of pi. Okay, so that is why I am telling pi. So this 3.14 something, 3.14159, 159. I can't remember the other numbers. So there's a lot of numbers, non-stop numbers, different numbers coming. But this 22/7, if you divide and check, it will be a rational number. So pi is another rational number. Irrational number, I'm sorry. Pi, even though we use it as 22/7, it is not equal to 22/7. It is actually equal to 3.14159,265, like this. Pi is an irrational number.